so here we're just asked to find out what K needs to be so that null A is a subspace of RK. So this is a 4 by 2 matrix, and so that the domain has to be, so remember I'm always multiplying A times X is equal to like 0, right? So since this is a 4 by 2 matrix, X here needs to be a 2 by 1 matrix, so K is 2. All right, so what about column A? The elements of column A I can see are in R4, so K has got to be 4. So this isn't saying find the spanning set or what the solution is for null A. They're just saying find one vector. I always know that X equals 0 is in there, but let's see if we can find one more. So is there a nice easy one that I can find that for sure will get me to the 0 vector? And I can't remember how I'm noticing between this column and this column, isn't there a factor of 3? So let's try 3, 1. So 2, negative 6, negative 1, 3, negative 4, 12, 3, negative 9. So if I take a multiple of 3 and 3 times this first column, 3 times this first column, 1 times that second column, that gets me to the 0 vector. So 3, 1 is an element of null A. And you could go through and solve it too. So let's find a non-zero vector in column A. One non-zero vector in column A. Well, I could pick a column, couldn't I? There we go. Or I could pick negative 1 times that column. Or I could pick the other column. So any linear combination of a column of A. All right, so here we have this next one here. They're giving us a vector, and they want me to find, this is the matrix A, so they want me to find the spanning set for column A. So what I'm going to do is I see that the variables or the free variables are here. So if I factor out B, I get 1, 2, 0, 0. And if I factor out a C, I get negative 1, 1, 5, 0. And if I factor out a D, I get 0, 1, negative 4, 1. So I can see that column of A, again, this is how you say it. You don't have to say the spanning set. You can just put the parentheses, and that means span of these 3 vectors, because I found the free variables. So linear combinations of these 3 vectors gets me to the column space of the matrix A. So this is breaking it up. All right, so these are a little bit different questions. Okay, so this is going to take a minute or two to get your brain around. So this is going from polynomials to 2 by 1 matrices. Polynomials of degree 2 to 2 by 1 vectors. And how it does that, it inputs a polynomial, and how you get the 2 by 1 matrix is you evaluate the polynomial 0 to get the first entry, and you evaluate the polynomial 1 to get the second entry. So here's an example to help you see. So here's my polynomial. So if this is my polynomial, if I put 0 in to this polynomial, I get 3, right? Put 0 in for t, I get 3. All right. Now if I put 1 in for t, I get 3 plus 5 plus 7, that's 15. So these are the numbers from plugging in 0 and plugging in 1. Okay, so that's a polynomial. This is what this transformation does. Okay, so now I want to find a polynomial in P2 that spans the kernel. What is the kernel? The kernel is null A. So what kind of polynomial will always take me to the 0 vector? Okay, so that's going to depend on what I'm evaluating at. See, I'm evaluating it at 0, and I'm evaluating it at 1. So I get 0. So I'm using 0 and 1 as the roots of my polynomial, right? Roots of my polynomial. So this is a polynomial that spans the kernel. All right, let's try another one. So here's a polynomial, here's a transformation, P2 to R2, and they're both at 0. So here I'm saying find 2 polynomials. Okay, so there can be different ones, right? So since they're both being evaluated at 0, could I say that t, just t, spans the kernel? So put in t equals 0, I get the 0 vector. What about p of t is t squared? Because it's the highest degree 2, right? I could use t squared. So just a little bit of creative thinking here. All right, last one. So here I've got at 1 and at 2. So by now you're really getting the hang of it, right? So I can say, okay, p of 1. Sorry, I should have put it's p of 1, p2, p of 1. So I'd have t minus 1 and t minus 2, the 2 roots, right? Wait a minute, what am I getting used for the second one? Another polynomial that spans